Hi, I'm Kent Lohman with Future Designs, and today we're here to talk about the new NXP LPC1788 microcontroller. We use the 1788, and for us it's a significant upgrade to the popular LPC2478 because it's a new 120 megahertz ARM Cortex-M3 core. So you've still got the popular embedded LCD controller that allows you to do graphical user interface in a single chip micro. You've got up to 512 kilobytes of internal flash memory and the 96 kilobytes of internal RAM. The part also includes two USB controllers, Ethernet controller, and external memory interface for flash and SD-RAM. The part's got a rich host of UARTs, I2C, I2S audio, SPI, and also an internal low power real-time clock that's very rich and full featured, very low power, and it's also got on-chip internal E² PROM. The part has a new windowed watchdog timer that increases reliability for safety critical applications, and it's also got a quadrature encoder for motor control applications. So in our world where we build graphical user interface controllers, some of the most important features for us are the on-chip integrated LCD controller. We're actually able to implement a 4-wire resistive touchscreen interface using nothing more than some A to D channels and software on the Cortex-M3. The fact that it is a Cortex-M3 industry standard ARM core allows you to use all the third-party software that exists and provides a rich wealth of third-party tools such as JTAG emulators and compilers. The new core, which contains an MPU, a memory protection unit, also means that we can not only run FreeRTOS Muse on our products, but we can run SafeRTOS using the memory protection unit. So for medical or safety critical applications, that's very important. The new part also includes a hardware CRC generator and checker, and that comes in handy in our in-application programming with our bootloaders to allow firmware updates from either the USB host port or over the Ethernet link. So those are some of the most important features of the 1788 to us. So one of the reasons we're here talking to you today about this new NXP part is because of our history with NXP and our overlap and synergy with them. NXP is a very important partner and customer for us. We're an NXP authorized design consultant. We've been a tool supplier to them for over 15 years. We're also a member of the ARM connected community, and we share a lot of other synergy in the distribution channel. For example, 3 of our main distribution partners are also franchised with NXP. Avnet Embedded is a partner with both FDI and NXP, and they're one of the largest suppliers in the embedded chain for boards and modules. DigiKey is the largest catalog distributor in the world, and they're a franchise partner for both FDI and NXP. And Mouser, who's another large catalog distributor, is also a franchise partner for both NXP and FDI. So part of what we want to talk to you about today to show the importance of the LPC1788 to us and our customers is the line of products that we make for graphical user interface. Now, one of the first questions you might ask is, why is graphical user interface so important? And part of the reason is everybody has seen iPhones or Android phones with the new sleek user interfaces, and the customer expectation has changed radically for what they're looking for in products. It's no longer acceptable to just have a monochrome keypad and a character-based monochrome LCD. In today's embedded products, you need an iPhone or touchscreen user interface, but you really don't have an easy option to get there in terms of a development schedule. So what we're providing in our Muse GUI family is an instant off-the-shelf option for graphical user interface or for human-machine interface applications. So what we provide is a fully integrated hardware and software solution. So you see here some of the products in our family. These are 3 of our standard products. All these products can be the main CPU in an application, or they can just be a slave graphical user interface to your processor. We have these products in distribution stock. As a matter of fact, all these products are LPC1788 based. We also offer customization options if you want different size LCDs, or if you're looking for hardware customization. And the products are cost effective even in high volume applications. So we mentioned that these are all 1788 based. We also have other processor options, but obviously this 1788 is one of the newest and most popular processors. These are examples of our standard products. This is our 4.3-inch Muse GUI, this is our 5.7-inch Muse GUI, and this is our 7-inch Muse GUI. All of these products offer 4-wire resistive touchscreen. We also have 5-wire resistive touchscreen options, and we're working on cap touch options for the future. We offer a variety of different expansion boards to support these, to bring out various other hardware, and we also offer plastic and machined housings to package these products in. The family is available as development kits, which come complete with JTAG debuggers, cables, and documentation, and they're also available as cost-effective board-level assemblies. So what the family does is allow you to easily upgrade the user interface in your embedded product. Okay, so now we're going to look at the Muse GUI block diagram, and obviously the processor is the NXP LPC1788. We're going to go around and look at the functionality of the board. The board contains a USB Mini B connector. This is primarily for USB device communications, and it's also our primary source of power for the unit. We've got a mini JTAG interface on the board for both programming and debug. The board contains a micro SD card, which allows you to have large amounts of storage for either graphics or data files. In the case of the development kit, we ship the unit with a 2 GB micro SD card, and the connector is available on all the Muse GUI board level assemblies. The product contains a 3-axis accelerometer, so we can do motion detection in the X, Y, and Z axis. A digital I2C temperature sensor, so you can measure temperature with roughly 1 degree accuracy in both Celsius and Fahrenheit. And we utilize the integrated low-power real-time clock on the LPC1788 to provide time-of-day functions and time-based interrupt functions for process control. The Muse GUI contains up 8 megabytes of SD RAM that's expandable up to 32 megabytes. And it also includes 8 megabytes of NOR flash that's also expandable up to 16 megabytes. The SD RAM is primarily used for the frame buffer for the graphics. The 1788 has 96K of internal RAM, but that's not enough memory for the graphical frame buffers that support the LCD screens. The NOR flash is optional code storage, or primarily is used for skins or graphics for the LCD screens. Board contains the LCD interface for the basic display, also backlight generators, and all the necessary control circuits for the touch screen. We offer 2 different expansion connectors which provide up to 70 I/O pins for I/O level expansion, and the expansion connector includes things like Ethernet, USB host, SPI, I2C, A to Ds, and DACs. This is an actual Muse GUI 4.3 printed circuit board assembly, and we'll just quickly show you some of the pieces we just looked at on the block diagram. Obviously this is the LPC1788 microcontroller. We use the 208 pin quad flat pack because the entire assembly is 100% surface mount. Allows us to keep the production costs down and also to mate the LCD directly to the back of the board. This is the USB device connector where we get communications and power. The JTAG interface connector for programming and debug. This is a mini ISP connector. We do support ISP programming as well as JTAG. And these are the two expansion connectors that provide up to 70 I/O pins for expansion. For example, in a slave-only application, you could come in through one of these connections on an SPI or a UART interface and communicate with the processor in a very simple manner. This is the SD card connector, the surface mount speaker, which I think we did not mention that in the block diagram level. Anyway, we support the surface mount onboard speaker. We've got the 8 megabytes of NOR flash, 8 megabytes of SD RAM. This is the super cap that provides the battery backup for the internal low power real-time clock. You see here the LCD interface for all the control signals as well as the touch screen and the backlight. This is the temperature sensor, the I2C digital temperature sensor, and the 3-axis accelerometer. So you can see that all the hardware is contained on the board that you most likely need in your application. And if you notice, this is the board level assembly that we offer in volume, fully integrated with the LCD on the other side. So in addition to the standard features that we offer on our Muse GUI 4.3, our larger Muse GUI products, such as the Muse GUI 7-inch, offer some additional features due to the larger board size. So on the Muse GUI 7, we also offer an onboard 802.11n Wi-Fi module from Redpine, fully integrated into the board and complete with an onboard wireless antenna. So we're able to offer not only Ethernet wired communications, but also wireless 802.11n on the board. We've got an additional spot for 128 megabit serial flash memory as well. So in our standard family, we offer support, as we said, for a 4.3 inch, a 5.6 inch, and a 7-inch Muse GUI as standard off-the-shelf products. The products you see here are all running the NXP LPC1788. In addition, they're running Safe RTOS, and in support of third-party graphics beyond the open source swim library that we offer as part of Muse, we've partnered with several other people. These include Blue Water Embedded for Prism, Swell Software for their PEG graphics library, and Sagar for their EMWin library. The unit we have here on the 7-inch side has a Sagar EMWin demo on it that we can show you. And if we go here and touch the icon, and these are all available on our website and also on Sagar's website. This is going to go through and run the full-blown EMWin graphical demo. EMWin is a much more powerful purchased software product that gives you WYSIWYG, what you see is what you get, graphics development on a PC environment, and allows you to then port those graphics over to the embedded environment to the LPC1788. We offer in our Muse free RTOS library basic drawing primitives in SWIM, but this is a much more powerful third-party application that allows you to develop much more complex graphics. There are versions of EMWin available for purchase in object code only for as little as $5,000, so it's an affordable package as well. One of the other things we'd like to do today is just give you a quick out-of-box demo on one of our basic Muse GUI products. So I've got a Muse GUI 4.3 here, and this is exactly as it would come out of the box. So you can see it's the complete hardware solution. In this case, I'm actually using a small USB battery pack to power the unit, so I don't have to have a power cord plugged in. Makes a good source of power and an easy demo to pass around. Okay, so what you see here is the basic Muse and SWIM generated icons on the product, and all of this software is contained in the unit and is available open source on sourceforge.net or from our website, www.musegui.com. You can see the product contains a basic slideshow. What this is very similar to what you've seen in a picture frame application. We've got some FDI PowerPoint slides on here, but we've also got some very pretty graphic slides, and you can see that it will sit here and animate and just scroll through the slides. So very, very nice, powerful graphic application at a demo level. So if we exit out of that and go back to the main menu, We've also got a simple drawing application that's contained on here, so you can do basic drawing functions, change colors, and you can save what you've created to the SD card, and you can load it back, for example. There's also to illustrate the power of the 1788, we don't do full motion video, but we've got a simple graphics rendering on here where we've taken the 3D model for the enclosure for the 4.3 inch Muse GUI. We've got it packaged in an ABS enclosure, and we're rotating that through JPEG renderings to just show you what is very simple video rendering and animated motion. So that gives you some idea of the basic functionality of the product out of the box.